everyone, my name is Isaac from the Innovation Consortium, and today I'd like to share with you about a precision measuring instrument, and the instrument I'm talking about, it's a micrometer. So it's what we are going to be looking through for today. And to start with, I'd like you guys to take a physical view of what a micrometer looks like, so as we can go further on to understand how it works, where we use it, and how to read the dimensions on the micrometer. Now on my table here, I'm having this instrument you're seeing here, and this is what we call a micrometer screw gauge. It's called a micrometer screw gauge. If you've ever came across an instrument like this one, it's what we call a micrometer screw gauge. What it is, how to use it, and how to get the readings, and how to actually to read or to understand the readings on the different scales of this micrometer, I'm going to be explaining, and hopefully by the end of this clip, I hope you'll be well conversant, or you'll be able to understand how to read the micrometer. So to start with, the basic definition, or how I can define a micrometer, it's just an end-to-end measuring tool, but for it it's precise. So to redefine it, I can say it's a precise end-to-end measuring tool we use to ascertain dimensions on different parts or machine pieces, or anything we do in the workshop. It could be a plate. Take for instance, if I have a plate and I want to measure the thickness, I can use a micrometer. If I have a shaft and I want to take measurements of the diameter of the shaft, I can use this very same instrument. So it gives you the readings, but they are precise to an accuracy of 0.01. So that's basically how I can define a micrometer. Now, before we go to how to use the micrometer, I'd like you guys to know the main parts basically of this instrument of ours when you're using it to measure, so that when I go to the measurements, when I talk of maybe a term, maybe a thimble, a barrel, you'll be able to know what I'm talking about, what a spindle is, what a barrel is, what a thimble is. You'll be able to be knowing all of those. So I'll be talking about the different parts, and you'll be seeing them physically. So to start with, here's our micrometer. The blue part you're seeing here, it's what we call the frame of the micrometer, the blue part. It comprises of the nut and the anvil. So basically it's the frame. You're seeing the blue part here. The micrometer, it has an anvil. I'll be opening it a little bit. You can see at the extreme end of the frame, we have this hardened piece. It's what we call the anvil. This anvil, it's where one end, we place it at the end of the workpiece. We said a micrometer is an end-to-end measuring tool. So, of course, the reference, you have to be having an end, a starting point, which will be the anvil you're seeing here, and the moving end, which is the spindle you're seeing here. So this is the anvil, and this is the spindle you're seeing here. Why we call it a spindle? As I rotate, the spindle goes back and forth. So it's a spindle. It closes and opens to widen the gap as you're taking your measurements. So we are having a frame, the blue part, we are having an anvil, we are having the spindle. So those are three so far. We said we are having a frame, we are having an anvil, we are having a spindle, and we are having this component you're seeing here, which is having dimensions. This one we can call it the barrel or the sleeve, as you're seeing. It's also graduated with some readings, as you can see. The ones in black, those are readings, and we shall explain them later on. It's called the barrel or the sleeve, this one you're seeing here. Then this part which moves, it's also having readings, but for them, they are circumferential. So this one is what we call the thimble, as you can see. The one which rotates, it's called the thimble. And finally, we have the ratchet. This component behind here, it's called the ratchet. So basically, those are the main components of the micrometer. To repeat again, we are having a frame, we are having an anvil, this part here you're seeing, we are having a spindle, we are having a barrel or the sleeve, then the thimble, then the ratchet. Why a ratchet? Let me show you why we call it a ratchet basically. When I close my micrometer fully, you'll hear the ratchet making that clicking sound. So as we don't force or over tighten, it has the torque, the required torque when you're tightening, or when you're tightening the micrometer on the workpiece you're measuring. So when it's tightened, the ratchet won't allow it to tighten or over tighten onto the workpiece. So it's a ratchet, a thimble, a barrel, a frame, spindle, then an anvil. So basically those are the main parts of the micrometer. Now going further on, how to read the micrometer. It's what we are going on. After understanding the different parts, then we shall be heading to how we read the dimensions or different dimensions on the micrometer. First of all, I'd like to explain how to use it on the different workpieces we are measuring. When I open the micrometer by the use of the ratchet, as you can see, when I rotate it anti-clockwise, I'm widening the gap. It's like I'm loosening the nut. The spindle is going backwards. And when I rotate it, the ratchet clockwise, I'm closing the gap, as you can see, so that I ascertain the different dimensions. It could be a thin plate. You have to close so that it reaches the thickness of the plate. When it's something like a shaft or a rod, a round rod, you open, you widen the gap, then you take the different measurements of the workpiece. So basically, I'm going to show it to you physically by taking some measurements on different workpieces. As I was explaining, we shall be making an experiment of taking the measurements of the thickness of this steel rule and the diameter of this shaft. So first of all, we are going to see how we adjust the micrometer so as it fits onto these two different thicknesses or diameters or dimensions practically. So we shall start with a steel rule, as you can see. For a steel rule, our micrometer is widely open. We said we rotate it anti-clockwise so that the gap widens between the anvil and the spindle, and we rotate it clockwise with the ratchet clockwise to decrease on the gap between the anvil and the spindle. So whenever you decrease, you're ascertaining or you're measuring dimensions of a thinner piece. Whenever you widen, you're taking dimensions of a bigger or a thicker piece. So to take dimensions of a thinner piece, we shall be we shall have to close the gap between the anvil and the spindle. So as we take the measurement of the steel rule, as you can see. So basically here we shall be closing the spindle. As it approaches the anvil, we place our steel rule in between the anvil and the spindle faces. So we tighten. Remember we said we tighten using the ratchet. The ratchet is this unit we saw up. So when you tighten and you hear that clicking sound, just know the faces, or you've got the required torque. The faces have met with the surfaces, the bottom surface and the upper surface of the steel rule. So the anvil is touching the bottom surface. The anvil is touching the bottom surface of the steel rule, and the spindle face is touching the upper face of the steel rule. So when I use the ratchet, it gives the torque, the required torque to the faces. Then I ascertain the dimension or the values or the dimensions of the thickness of the steel rule. So basically that's how it works. So to take another example, we shall be taking another example of a shaft. It's a round shaft. Still, we do the same. Now after knowing how we can measure the thickness or thinner pieces, it's a steel rule. We measured the thickness of this steel rule. It's thinner compared to the diameter of this shaft. So we shall be heading to how to measure thicker workpieces. So the vice versa, we say to widen the space between the anvil and the spindle face, we just rotate anti-clockwise, and the gap, we shall be unscrewing the spindle. Basically, it's why we even call it a micrometer screw. You hear the term screw. It's a screw, it's a spindle, but it's in a form of a screw. So it's like we are screwing it, we are screwing the spindle backwards or anti-clockwise to widen the gap, so as to ascertain the values or thicker values of the diameter of this shaft. So practically, we shall unscrew the spindle, so as it widens, then we shall be able to put the two faces, the face of the anvil and the face of the spindle, onto the diameter of the shaft. So we do the same. We screw clockwise the spindle. It's like we are moving the spindle to approach onto the face of the diameter, actually the diameter of the shaft. So it's the same principle. As it clicks, as the ratchet clicks, you stop the tightening. It normally clicks thrice. It's already done. You've already tightened to the maximum torque of the spindle or of the micrometer. So only 3 times are enough. As you hear, 1, 2, 3. It's already tight. So you just remove it off. Then you read the dimensions on the scales of the micrometer. So these are the scales. There is a scale on the sleeve, there is a scale on the thimble, and those are the 2 main scales, actually on the sleeve and on the thimble. So basically, after taking the dimensions, we just get the readings. That will be the accuracy of the dimensions of any object we've measured. So basically, that's it on how to use it. So how to read the dimensions you've got on the different workpieces, the thickness of the steel rule and the diameter of this shaft. So we are going to be heading to the actual readings, or how to read the dimensions on the different scales of the micrometer. The micrometer has three main readings. So basically today we are looking at a metric micrometer, and it's the one we commonly use in our basic works, the metric micrometer. The other micrometers, there is another one in inches, there is a vernier micrometer. So, but basically the most common type of micrometer we use is this metric one. So it's the one I'm going to be explaining about, on how to read, on how to interpret the scales, the different graduations on the scales, and how to get the final reading on the scales depending on what you've measured or the dimension you've measured. To start with, I'll be explaining the different scales on the micrometer. So how to ascertain the values, or how to read, to get the readings on the different scales of the micrometer. So we shall start by understanding the different scales of the micrometer. Remember we said we have three scales on the micrometer. We have the main scale in millimeters. We have the half millimeter scale. We shall start by understanding the scales we have on a micrometer. We have the main scale in full millimeters, the one you're seeing up here. We have a main scale in half millimeters, the one you're seeing at the bottom. We say the upper one is a main scale in full millimeters. We have the bottom one, it's also a main scale but in half millimeters. And the line you're seeing here, it's what we call a datum line, or our line of reference. And the other scale is the one you're seeing on this thimble. These two scales, both of them are on the barrel or on the sleeve, and this one scale is on the thimble. So we are having three of them. We have the main scale in full millimeters, we have a main scale in half millimeters, and we have the thimble scale, which is on the thimble. So it's also a scale, but it's on the circumference of the thimble, as you can see. It starts with a 0. As you rotate, it goes back to 0. So it's having actually 50 divisions. It's having 50 divisions. So we are going to be explaining all the scales, so as you understand very well every scale and the purpose it serves on the readings, or on the final reading we get on any object we've measured. To get the readings, or to know how to read the measurements as referred to the scales on the different scales of the micrometer, we shall start by understanding the different scales. We have the main scale, as I had said, it's a main scale reading in full millimeters. Later on we are going to try to magnify them on our whiteboard, but we shall start by seeing them. We have the main scale in full millimeters. The dimensions are in millimeters actually. It's like you're having anything or a steel rule, the dimensions in millimeters, as you can see. It's the same scale, they are in millimeters. The other scale, the bottom one, so the gap between 1 millimeter, it's the same gap of the scale on this steel rule. So basically they are just millimeters on this barrel, the barrel readings actually, the barrel scale. So it's a scale in full millimeters, and there is another scale we are having in half millimeters. The only difference, this barrel scale in half millimeters, it's in the middle, or they graduated it, or they marked it. It's the same scale, they are all millimeters, but for it, it's halfway. So the bottom scale is a scale also in millimeters, and they are the same millimeters. as the ones we talked about on the steel rule. So they are also millimeters, but why we call them half millimeters? They are halfway, they are graduated halfway of the graduations of the barrel scale in full millimeters. So for them, they start halfway, between the graduations of the barrel reading in full millimeters. That one, actually, I will be explaining it on when I magnify it on our whiteboard. That's when maybe basically you can understand it. So they are halfway of the graduations of the main scale in full millimeters. So their graduations, actually their readings in half millimeters. So the other scale, it's the thimble scale, and for it, the graduations, there are 50 graduations, meaning the whole thimble, it's divided into 50 equal graduations. So we shall be explaining it further on our board. To magnify what I've been explaining about, I'll draw a magnified view of these scales, and I hope you'll be able to understand how the scales read and how they are graduated on the barrel and on the thimble. So I'll draw a simple sketch of a barrel. This is a barrel, remember. I'll draw a front view of how you view it front-wise. So it will be like this. Basically, this is the barrel. And I'll have to draw the thimble also on the front view so that we understand how these readings come about. So a barrel is somehow tapered here, like this. So this is our barrel. This is our barrel. So this is the barrel, and this is the thimble, to take the front view of it. So I'm trying to magnify it so as we understand basically all the scales on the barrel and on the thimble. So there is a scale I showed you. There is this line I showed you. It's in between. There is that line. I called it the datum or the reference line. That line is the one I've first drawn. Then up, we are having a scale, as you can see. There is that upper scale. It's in millimeters, the one we talked of. The barrel scale in full millimeters, it's the one up. Then we talked about the barrel or the sleeve scale in half millimeters. You don't get confused. So at times I might talk about a barrel and I could talk about a sleeve. So this whole unit you're seeing here, it's a barrel. It can be called a barrel or a sleeve. So there are two terms, but they are meaning the same component or the same part of the micrometer. So it's only this which we are calling a thimble. So they are barrel readings in full millimeters. They are the ones on the upper side, the ones you're seeing here. They are the readings in full millimeters, and they are barrel readings or sleeve readings, barrel readings or sleeve readings in half millimeters. So there is another scale on the micrometer you're seeing down. There are graduations down. For them, they have no markings. These ones, the upper ones, they are having markings. There is a 0 from 0, 1, 2, 3, 4. You go to a 5, 6, 7, 8, 9. You go to 10, 11, 12, 13, 14. you go to 15. So for them, they are marked. The upper ones, the readings in full millimeters, they are marked, but the readings in half millimeters, I say they don't coincide or they don't align with the graduations of the barrel in full millimeters. For them, they start halfway. They just start halfway in the half. So they just keep on going. Remember, they are also millimeters. So when you start a millimeter halfway, meaning the other millimeter will be halfway also, the other one will be halfway, and so on and so forth up to the end of the range of your micrometer. They'll be going just halfway, and we are going to be explaining why it's that way. Now to go back shortly, I'll be explaining about how to read these dimensions, or how to read dimensions of a micrometer. So before I understand how to read these dimensions, I'll be first talking about shortly the working principle of this micrometer. A micrometer screw gauge, it's having a screw actually. It's a screw with threads, and those threads are having a pitch of 0.5 millimeters. 0.5 millimeters. So it's a micrometer screw gauge, but it's having a screw. With a pitch, a screw with a pitch of 0.5 millimeters. So whenever we rotate our thimble from this zero, a thimble is also having graduations. It's also having graduations from 0 A thimble is also having dimensions graduated on it to its circumference, and they read from 0 to 50. There are 50 equal graduations on the thimble. They are equally divided, and their reference, it's this line we drew at first. It's their reference point, or the starting point, or the datum where we read these dimensions on the thimble. It's the reference or the datum. So ideally, these graduations are 50, as I had said earlier on. So whenever I rotate one complete revolution of a thimble, that means I've rotated 50 graduations of the thimble to the main scale. But what distance does it move whenever I rotate one complete revolution of a thimble? One complete revolution of a thimble, as you can see from my micrometer here. Let me close it entirely. When it's locked, it's on a 0, but one complete revolution of a thimble, when I rotate from 0 and I bring back to 0, one complete revolution moves half of a millimeter or 0.5 of a millimeter. So basically, whenever I rotate the thimble, and that's the main importance of this scale, the bottom scale in half millimeters. So whenever I rotate the thimble to one complete revolution, it will move half of a millimeter. That is 0.5 millimeters. So whenever I rotate, if I rotate it twice, that means 0.5 two times. That means I've rotated a full millimeter. So when I rotate, here it's now closed. When I rotate from 0 to 0, we say that's half a millimeter. I rotate again from 0 to 0, that's a full millimeter. And it will be shown on the scale in full millimeters and on the scale in half millimeters. So if I'm to rotate a full millimeter, that simply means I have to rotate the thimble. I have to rotate 2 revolutions of a thimble to get 1 full millimeter. Hopefully we've understood that. So going back to the working principle, we talked about a micrometer having a screw, a micrometer screw gauge, so whatever we are doing, we are playing around with this screw. So ideally, this screw is what we are playing with, a screw with a pitch of 0.5 millimeters. So whatever we are doing with the micrometer, either loosening or tightening or an adjustment we do with the micrometer, we are playing around, or we are traversing, or we are opening or closing the screw. And the screw is with the spindle, basically. So whenever I unscrew, the spindle goes backwards. Whenever I screw, the spindle goes inside to reduce on the gap. So basically, it's how a micrometer screw gauge works. So talking of a pitch, there is a nut and there is a screw. So the nut, it's also with the same pitch of 0.5 millimeters. The screw is also with the same pitch of 0.5 millimeters. Now getting the accuracy of the micrometer, we get remember the accuracy, as I said before, in our definition of the micrometer, it gives you an accuracy. The metric micrometer gives an accuracy of 0.01. These are millimeters. But how do we come to this 0.01 millimeters as an accuracy? I'll be explaining how we will be able to ascertain the 0.01 as an accuracy on the micrometer. On how we arrived to the accuracy of 0.01 of the micrometer, the accuracy and the working principle, I'll be explaining them so that we understand where we get the 0.01 or the accuracy of 0.01. We said the thimble is divided into 50 equal divisions. This is our thimble, as you can see. and the scale is this one. It's divided, when you count from 0 and you come back to 0, this very 0, you'll count 50 equal divisions divided on the scale of the thimble. So we note this somewhere here. There are 50 equal divisions on the thimble scale. On the thimble scale. So one complete revolution of the thimble means it moves one, let me just write it down, one complete revolution of the thimble scale, moves one complete revolution. This is the thimble scale. When I rotate it 360 degrees from the start to the start, from 0 to 0, that's what I mean by 360 degrees. When I rotate it from 0 and I bring it back to 0, it moves the main scale. It moves the main scale. It moves the main scale. The main scale by 0.5 millimeters. So if I'm to re-explain it, whenever I rotate the thimble scale from 0 and I move it 360 degrees, and it comes back to 0, I move the main scale. This is the main scale, you see here. I move the main scale by 0.5. So the barrel moves off the main scale by 0.5 millimeters. It doesn't matter whether you're closing it or when you're widening it or when you're closing it, it's all the same. One complete revolution, if it's backwards or in front, it moves the main scale by 0.5 millimeters. We shall see it physically with our micrometer. So whenever it's closed, we said it's closed on a 0, on the 0 mark. Said it's closed on the 0 mark. So whenever I open from 0, as you can see, we said we rotate it anti-clockwise when we want to loosen or we want to open. So whenever I open it from 0 anti-clockwise, then I bring back to 0, as you can see. It moves the main scale to a distance of 0.5 millimeters, as you can see. You can see the upper side. We're only having one graduation, seeing the starting graduation of a 0. We are only seeing a 0. We are not seeing any other graduation. But the only graduation we are seeing is the bottom one in half millimeters. So that's the main role of the scale in half millimeters. So that's when you confirm that you have moved the reading by half of a millimeter. So that's the basic importance of the scale in half millimeters, as you can see. So I've moved a complete revolution, meaning I've moved half of a millimeter. So the bottom scale will be showing me that half millimeter, but the upper scale, I'm on a 0.5, so we are not seeing any other graduation. So it's the bottom scale which shows us that we've already moved half a millimeter. So when I rotate another revolution, that means I'm taking 2 revolutions. When I rotate from that same 0 and I bring it back to 0, remember the 0 has to coincide with this line you're seeing here, which I called our datum or our reference or our starting point of any measurements on the thimble scales. So I have to move the 0 from that line and I bring it back to that line. So meaning the 2 revolutions I've moved 0.5 twice. So 0.5 times 2, or 2 times of 0.5, we are having 1 full millimeter. So basically, I have to move the thimble 2 times to get a reading of 1 full millimeter. So basically, for the start, those are the 2 scales. But in depth, to explain more, we are still explaining about the accuracy, but I wanted to first show you practically how the scales move. So with the accuracy, remember we said 1 complete revolution of the thimble scale moves the main scale by 0.5 millimeters, as you saw on our micrometer here practically. When I move the thimble scale from 0 and I bring it back to 0, it moves 0.5 millimeters. Now, how do we arrive to the accuracy? So whenever I move one graduation of the thimble scale, so it's also graduated, as I had explained earlier on, but it's graduated into 50 equal divisions. So this is the thimble scale. So when I move only one from 0, and I only move 1 gap out of the 50. If I move only 1 gap, or only 1 graduation of the thimble scale, we said 1 graduation. By graduation, I mean the marking, the graduations, as you can see, these are what we call the graduations. The marking you're seeing, which I embossed on the scales. So from here to here, I'm calling this 1 graduation. From here to here, I call that 1 graduation. So it's a mark, a gap between the two lines. Those are the graduations I'm trying to mean. Or 1 graduation, or 1 mark of the thimble scale out of the 50 marks or graduations. Still, I've moved one out of these 50. We say there are 50 graduations on the thimble scale, which are equally divided. So if I move 1 out of the 50 graduations or marks or markings on the thimble scale, still, we are still on the thimble scale. Now we multiply this by the pitch. Remember we said our pitch is 0.5, the pitch of the screw of the micrometer, or whenever I rotate, or whenever I move 1 graduation of the thimble scale out of the 50 marks, then I multiply this by the 0.5 the 0.5, this is the pitch, of the spindle screw, actually, of the spindle screw. The spindle screw, we say this is the spindle. It's the one which moves back and forth. So the screw, we said it's 0.5, the pitch of the screw. It's what we multiply by, so as the final measurement we get will be the accuracy of the readings we are getting on the micrometer, or it's the accuracy of the reading the micrometer gives us. When we get the calculation, or when we ascertain the final value of this formula, which hopefully I think will make us arrive to the accuracy of the micrometer. So we shall take a simple calculation. Simply, when I divide 1 out of 50, this one graduation of the thimble scale out of the 50, I'll be getting a 0.02. Then I multiply it by the pitch of the spindle screw of the micrometer screw gauge, which is 0.5. So if I multiply 0.02 times 0.5, my final answer will be 0.01. All these, remember, are in millimeters. So giving us the accuracy of the micrometer, which is 0.01 millimeters. So that's how we get to the accuracy of the micrometer. Now, hopefully, we've understood how to get the accuracy of the micrometer. Now we shall be talking of how to read the scales of the micrometer once I've taken any reading or any measurement with the micrometer. Practically taking the readings of the micrometer or reading the scales to ascertain the value we've measured on the micrometer, we shall take a practical view of our steel rule. We said we open the faces of the spindle and the one of the anvil, then we close with the use of a ratchet. Here we are measuring the thickness of this steel rule. So we open, then we tighten. We make sure the faces of the spindle and the face of the anvil of the micrometer are all touching the workpiece we are measuring. So we are measuring the thickness of this steel rule. So all the faces are touching the flat face of the steel rule and the bottom face. So we tighten with the use of the ratchet. Remember, we said it only has to click only 3 times. That shows you've already achieved the torque or the tightness you need so as to measure, to start reading the dimensions on the scales. So as you hear that clicking sound of the ratchet, it clicks once, twice, and it has to click only 3 times. 1, 2, 3. So you've already achieved the tightness you need on the micrometer faces, the face of the anvil and the face of the screw or the spindle basically. So there you remove off the micrometer of the workpiece you've measured. Then you read the dimensions on the different scales. But to start with, I'll be magnifying the scales on our board. The drawing we had before, the front view of the scales, we are having a scale. We had a drawing in this format. this is our barrel or the sleeve, and it's the front view of the barrel. This is the thimble. As you can see, it's just a front view. Hope you get a clear image of what I'm talking about. And we are having this line, the line of reference. It's a reference line of the thimble scale. Then we have the graduations on top of this reference line. We have graduations. Remember, we said the top graduations, they are in full millimeters. So we measure. Remember, our micrometer was in the closed position, so meaning our 0 could be somewhere here. Then the millimeters, the full millimeters, start from here, and so on and so forth. So this is our reference line. So below, we are having the half millimeters, a scale divided into half millimeters. Remember, we said for it, it's halfway. It's between the graduation of the scale in the full millimeters, just in between. It's where the graduations start from. And they are also in millimeters. But why they are called half millimeters? It's because they start from halfway of the main scale in full millimeters. They start halfway of the main scale in full millimeters. So the main scale in full millimeters is this one up, and the main scale in half millimeter is this one at the bottom. So these ones start just halfway of the graduations of the markings in full millimeters. They just start halfway and they go on and so forth. So if we are to take the measurement, as you can see there, we first take the reading. The first reading is the reading. The first reading. What dimension do we read first, basically? The first reading, what dimension do we read first? So the first reading we take is the reading on the main scale in full millimeters. So it's this reading we first read. These are full millimeters. A basic full millimeter, as I told you, the one on a tape measure, the same millimeter is the same on the scale of a vernier caliper. So they are readings in millimeters, just millimeters, as you hear millimeters. The same readings on a tape measure in millimeters. They are the same, all millimeters, as you can see, the bottom ones. These are millimeters, the bottom ones, the bottom graduations. These are millimeters on this steel rule. Those are millimeters. On the vernier caliper, these are also millimeters, the bottom ones. So the spacings on a vernier caliper are the same, the spacings in millimeters, the bottom ones. They are the same spacings, the same size actually of the spacings of the millimeters on a steel rule. They are the same spacings. And they are the same on the tape measure. As you can see, the bottom scale, this bottom scale, the spacings are of the same size, since they are all millimeters. Hope you understand me very well. The same applies to a micrometer. The millimeters, the barrel readings, or the scale in full millimeters on the barrel, I can open it somehow and you see the readings. These readings you're seeing here, they are in full millimeters. They are basically millimeters, as I had explained on the tape, the vernier, and the steel rule. They are also millimeters. So it's the first reading or the first dimension we take. So we read them. They are millimeters. The same way you read millimeters on the tape measure, it's the same way you read these millimeters on the barrel. So they are full millimeters. So you just count from a spacing. This is 1, this is 1, this is 2. So meaning the readings I'm having, the first readings I'm having on this example of ours, or this practical example of ours, the reading I'm having, remember we say the first reading we take is the reading, the first reading we take is the reading, is the reading of the sleeve. We said it's a sleeve or a barrel. The readings of the sleeve or barrel in full millimeters. So we take the readings, you just count them. Simply, they are millimeters. 1, it's 1, 2, basically. So here, after taking this reading in full millimeters, you go to the second step. What's the second reading we take? It's the reading in half millimeters. The second reading you take, the second reading we take, it's the reading in half millimeters. Half millimeters. So where are our half millimeters on the micrometer? We had already explained where the half millimeters are. It's just this scale beneath the scale in full millimeters. So it's the reading we take. Remember, I told you they are also millimeters, but why they are called half millimeters? It's not basically that it's half of a millimeter, but it's because the readings are not coinciding, but they are halfway between the readings. If I'm to magnify this scale, the scale of half millimeters and the scale of full millimeters, so you'll take a closer look. If I'm to magnify it, this is the scale in full millimeters. This is our 0. Then this is 1 millimeter, 2 millimeters, 3 millimeters, 4 millimeters. This is 5, 6, 7, 8, 9. This is 10 millimeters. So the half millimeters, for them, they'll be starting in the middle here, as you can see, but they are also millimeters, remember. They are also millimeters, the same size of the millimeter. They are the same size of the millimeters on the full barrel, the full barrel scale. They are the same size. So it's a millimeter starting halfway, meaning 1 will be here, then 2 will be here halfway, 3 will be here halfway, 4 will still be halfway, 5 will be here, then 6, 7, 8, 9, 10 will be here. So they won't be coinciding, but they will just be halfway of the millimeters of the full barrel scale. So basically that's why they are called half, but they are also millimeters. So After getting the readings, the first readings of the barrel in 4 millimeters, we say they are these ones up on the upper side. Then after that, we take the readings in 0.5 millimeters. Still, this is still also the sleeve of barrel scale. So all these scales are on the barrel. This is what we call the barrel you're seeing here. It's a barrel or a sleeve. So the measurements we take first, or we read first, are the measurements in 4 millimeters on the barrel, these ones up. Then secondly, we read the measurements on the barrel in 0.5 millimeters. They are these ones at the bottom or beneath the other ones on the top. So these ones we can also count. Remember we said they are halfway. This is 1 millimeter. Then we are not seeing any other. So we just count. They also start from a 0. Then it's 1, 2, 3, and so on and so forth, as long as the scale goes. So the third reading we take, is the reading actually it's the thimble scale reading. It's the third reading we take. And remember our thimble, we said it's this one here. It's also having graduations. 1, 2, 3, 4, 5. 1, 2, 3, 4, 0, 1, 2, 3, 4, 5, 6, 7, 8, so and so on and so forth. So from 0 we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to the full circumference of the thimble, as we had explained. And as you can see, to the full circumference, this is our thimble. So they start from 0, as you can see. As you rotate the thimble 360 degrees or a full revolution, and it comes back to 0, there are 50 of them. So we expect our reading here, this one to be 49, and this making it, the gap here making it a 50 to our starting point of a 0. 49, here 48, here 47, 46, here you have a 45, and so on and so forth. So the barrel, it's also divided into 50 equal divisions. So mainly, these are the 3 readings we take, and the total or the sum of these 3 readings will be the accuracy of the measurement you've taken. Hope I'm understood. The sum of these 3 readings, the reading of the barrel reading in 4 millimeter, and the reading of the barrel reading in 0.5 millimeter, plus the reading of the thimble scale, when we add the 3 of them, we get the accuracy of the reading on our micrometer basically. So practically, we are going to take 3 or 4 examples so as we understand how to read the micrometer, the dimensions on the micrometer very well. Now fully understanding the readings or reading the scales or getting the final value of the reading you've measured on an object. Take for instance this shaft. If at all you've measured the shaft or the thickness of this steel rule. So I'm going to be explaining it practically so as we understand how to get the final value. So take an example. These are examples, some examples. We shall give something like 3 or 4 of them, and hopefully by the end of it we shall be able to understand how to read the scales or how to read the final value of the micrometer. And the final value will be the size of the object or the workpiece you've measured. So take for instance, we say this is our barrel, simple sketch. This is our barrel here. This is our thimble. This is our barrel. This is the thimble. This is the barrel. The barrel has a datum line, but the datum line is for the thimble, not for the barrel. So the barrel, the thimble readings, they use this line as their datum or their reference or the starting point of the measuring of the divisions on the thimble. So here on this datum line we have the graduations in 4 millimeters, and they start from a 0. There is 1 millimeter, 2 millimeters, 3 millimeters, 4 millimeters, 5, 6, 7, 8, 9, 10, 11, 12, 13, and so on and so forth. So the ones in half millimeters, they'll be at the bottom. They also start from a 0. But we should take note, in most cases and in most times, the graduations in half millimeters, they are not numbered, or they have nothing like, or take for instance the ones in 4 millimeters, they are numbered. From 0 you count 1, 2, 3, 4. You'll find a 5 when it's numbered. But the ones in half millimeters, they are not numbered, and they are always on the same length. From, let's say 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and so on and so forth. So they are just like that. They are plain, nothing like a numbering or a graduation showing the number of the divisions in half millimeters. And as I explain, you'll be able to understand why they are not even numbered and why they are in more, to understand more why they are in half millimeters. So if I'm to take the reading I'm having here, take for instance, I want to know the reading, the exact reading I'm having here, but I'll first have even to number the thimble scale. So if I'm having my micrometer when it's open, as you can see here, when it's open like this, now if I'm to ask, if anybody asks you what reading am I having on my micrometer here, remember we said you start by reading. We give the readings. We first give the reading in 4 millimeters. This is equal to, we count the graduations in 4 millimeters as much as you see, or the ones you see on the scale. You just count them, but basically they are even numbered. There is a graduation or the numbering. From a range of 5, there is a numbering. Another 5 graduations, there is a numbering of 10. Another 5 which go in, there is a numbering of 15, 20, 25, 30, and so on and so forth. So you can count, you can count, this is 1 millimeter, 2, we are starting from a 0, 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So the reading in 4 millimeters, this is a barrel. A barrel or sleeve. A barrel or sleeve reading in 4 millimeters. This is our barrel or sleeve. So we first take the readings, the barrel readings in 4 millimeters. Remember, we counted to 13, which is equal to 13. Remember, our accuracy is 0.01. So whichever figure we write on the board, it has to be to an accuracy of 0.01. So the reading we are having here is 13.00, because we can't see any other graduation on the barrel scale. Actually, any other 4 reading on the barrel scale. So it's a 13.00. So the second reading we take, this is the first, the second is the barrel or sleeve scale reading in half millimeters. Now, here's where we have to understand very well. The ones in half millimeters, for them we don't have to count them from 0. Maybe, let's say here we are having 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. They can't be 12 half millimeters basically. But what they help us with is to know whether the reading in 4 millimeters is having a decimal of a 0.5, or we've jumped to a 0.5 of a millimeter. Hope we understand that. What they help us, remember we said a complete revolution of a thimble moves 0.5 millimeters. So the half millimeters below help us to know whether the millimeter, whether the 4 millimeter on the barrel or the barrel reading in 4 millimeters has been exceeded by a 0.5. That's the main importance of this bottom scale in half millimeters. So we normally take a closer look around this point here. So if I'm to magnify it, it will be like this. We are having these ones. This is our line here. I'm magnifying it. We are having, these ones are the 4 millimeters up, the barrel readings in 4 millimeters. 1, then 5, 1, 2, 3, 4, then 5, 1, 2, 3, 4, then 5. Then the ones, sorry, I was trying to magnify, but I've seen it's more or less, I haven't magnified. Let me try to magnify more. Before we go to this, actually, let me explain this to you so that we understand where a half millimeter helps us. So to magnify this, this is our datum, the line we said. This is the thimble scale. This is the barrel or the sleeve. So this is the thimble. If I'm to magnify, we start with our 0 here. 1, 2, 3, 4. Then we have a 5 here. This is our 5th millimeter. Then the 1.5 millimeters, they'll be coming here, halfway of this graduation. These are the half millimeters. The readings in half millimeters, the bottom ones. But remember, I said the half millimeters, they only help us around this place here to know whether the full millimeter have moved a full millimeter halfway or not yet. So how do we see that? If I'm having the same scale, as you can see, I'll draw it again. This is our thimble. If I'm having this scale, let's say this is a 0. I'm having a graduation here. I'm having another one here. This is 1 millimeter. These are 2 millimeters. I go, after knowing I'm having 1, 2 millimeters, 4 millimeters on the barrel. Then I go bottom. I've read the first reading. 1, 2, I'm having 2 millimeters. Then I go halfway. 1, 2, 3. There are 3, but remember I said we only concentrate here. These half millimeters just help us to know whether I've already moved halfway of the 2nd millimeter. So when you see this, this graduation after the 2nd millimeter, you just know I've already moved halfway of the 2nd millimeter, meaning I'm already having a 2.5 somewhere here. So I've already moved the barrel by a decimal of 0.5. Remember, I'm already seeing this. So these other ones behind, they have no value, they serve no purpose. But it's this one exactly here which shows you that either you've moved half of a millimeter or you've not yet moved half of a millimeter to get the accuracy. So we are having 2, 1, 2. Am I having a 2.5 somewhere here or no? If you see this, you just know you're already having a 2.5. If you can see this on the scale, once you open your micrometer, or once you've opened, or once you've taken a measurement of any workpiece, once you see this on the bottom line, then you just know that you're already having a 0.5 added onto the full millimeter. To summarize it, once you see a half millimeter down here, just here, within here, you've already taken the 4 millimeters that I'm having a 1, 2 millimeters. Once you see 1 at the bottom here, just know I'm already having a 2.5. But if you don't see it, like for instance, I'll take a third drawing. If it's like this, this is our barrel. I'm having this datum line, and I'm having the thimble. The thimble is like that. This is my 0. I'm having a 1. I'm having a 2. So this is 1, 2 millimeters. I'm already having 2 millimeters, 2 full millimeters actually on the barrel. 2 full millimeters. I'm already having them. So after getting these 2 full millimeters, I'll come at the bottom. The half millimeters, remember we said that this way, the halfway. Now there is another second scenario like this. If you come to the barrel, you're having 2, you've already read 2 full millimeters, and you're not seeing a half millimeter or a graduation of a half millimeter here. You just know I'm having 2.00 on the barrel scale, basically. You've not yet seen half of a millimeter somewhere. But if it's there, you just know I'm having a 2.50 already on the sleeve scale or on the barrel scale reading. Hoping we've understood this. When I have half a millimeter in front of my final reading of the full millimeters, the barrel scale, any graduation which comes here in front, and you can see it physically. If you can see it physically, that simply means you're already having a 0.5. Remember, whenever we rotate the thimble, we say a complete revolution, that is 0.5. So when I reach 2 millimeters, if it's exactly 2 millimeters, if it's exactly 2 millimeters, it will be in this format. It will be in this format. If it's exactly 2 millimeters, you will see on my micrometer or the barrel scale reading in this format. If it's exactly 2 millimeters. This is a 0, this is 1, then the 2 will be somewhere here. It will be exactly at the edge, and the half millimeter will be here and another one here. So this is 1, 2, and here the thimble scale will be at the 0. 0, then 1, 2, and so on and so forth. 1, 2. So if we are to read exactly 2 millimeters, that means we shall read 1, we shall count 2 graduations, and the thimble scale will be at a 0, and the half scale, we shall not be seeing any half millimeter anywhere here. So a full millimeter will have to be in front of the half millimeter. But once it's a 2.5, take for instance, I'll also take another drawing. If you want to see a 2.5, it will be in this format. This is our barrel. This is the thimble. So I want to show you how a 2.5 looks like. The sketch is a bit weird. Let me take another sketch. This is 2 millimeters, 1, 2, and the 0 on the thimble scale is coinciding with this datum line or the reference we are using. This line, I've explained it more than even 5 times. It's the reference. The 0 has to be aligning with this. So we are having a 2.00. So if I want to know a measurement of 2.50, I'll take a drawing, a simple sketch. It's going to be looking like this. This is our barrel or sleeve, and this is the thimble. This is the thimble. So a 2.5, how will it be looking like? This is our scale, the datum, the reference. So the scale, the barrel scale reading in full millimeters, or the sleeve scale reading in full millimeters. I repeat, I might be mixing the words a barrel and a sleeve, but they mean the same thing. It's the same thing. This unit here, it's a barrel or a sleeve. I can call it a sleeve this time around and I call it a barrel, but I'm meaning the same point. It's a barrel or a sleeve, and this is a thimble. So I'm showing you how a 2.50 will be looking like. So this is 0. This is 1 millimeter. These are 2 millimeters. 1 millimeter, 2 millimeters. Then the half millimeters will be just coming halfway of these graduations. Then 2.5, this will be showing also 0. So you'll be able to see half of a millimeter here, somewhere here. That's why I told you our main point of focus is here, at this point here of the micrometer. These half millimeters this side, they don't matter actually at all. It's only this half millimeter. It's either in front of this full millimeter or behind of this full millimeter. When it's behind, as you can see this way, this is our 2. Here, I'm magnifying it. There is this, and there is this. When it's behind this one, that means we are having 2 millimeters, as you saw here. It's behind here. When it's in front, like you see here, we are having a 2.5. Hope I'm understood. When it's in front, like this here, when you can see it in front, you're already having a 2.5. When it's behind, you're already having, you're only having 2 millimeters. Since you're not seeing any other half millimeter, the other half millimeter is hidden by the barrel. So you're not seeing it, meaning, the other half millimeter is hidden by the thimble. This is the thimble. It's inside the thimble. As you can see, the thimble is here. When you close, all graduations enter inside this thimble. When you open, they are visibly seen. When you close, they are entering the thimble. So here we are having 2 millimeters, 2.0, and here we are already having a 2.5, as you can see. So the half millimeters only help us around this zone here of the micrometer when we are taking any reading. The rest of the graduations you're seeing here, they serve no purpose, or they don't help us in any way. It's only these ones at this point here where we get the accuracy. They are the ones we consider. Now we are going to take another example and we take the reading so as we understand the main accuracy of the barrel, or the barrel accuracy, or the sleeve accuracy. Now we shall take a closer look at these two sketches. I'm going to draw another sketch. These two sketches, and I'll be trying to explain the readings, or the readings on these scales of the micrometer screw gauge. So to start with, we shall start with the upper one. We said we first take the reading, or the main scale reading, in 4 millimeters on the barrel scale. So this is the one in 4 millimeters, the upper one, as I had explained. So we are having 1, 2, 3. So the barrel scale reading, the barrel or sleeve, we said it's the same. Barrel or sleeve scale reading in 4 millimeters is 1, 2, 3. There are only 3 graduations we are seeing. 1, 2, 3. This implies the barrel scale reading in 4 millimeters is 3. Remember, the accuracy gives us a decimal, takes us to 3 decimal points, actually to 2 decimal points. So we shall be having a 3.00. Then we take the barrel or sleeve scale reading in half millimeters. So we go down here, as I had explained, we only focus at this zone here. Do we have any half millimeter in front of the 3rd millimeter on the full reading? If it's there, it implies we already have a 0.5 ahead of 3 millimeters. So this simply means we are having a 0.50. So any reading we are getting, it's to a decimal, it's to a 2 decimal point. If it's a 3 on the main scale of 4 millimeters, it's a 3.00, and if it's a 0.5, it will also be to a 2 decimal point value. So we shall be having a 0.50. So it can't be 0.5. Yes, it's a 0.5 ahead of 3 millimeters, but it will be, we shall write 0.50 because it's the accuracy of the micrometer. Any measurement we write, it's to a 2 decimal point value. So the 3rd reading we take, it's for the thimble scale, the one we are seeing here. As you can see, there is a 40, 41, 42, 43, 44. So the measurement which is aligning with the datum, it's the one we take. Remember, we say this line you're seeing here is the datum or the reference we use for measuring the graduations on the thimble scale. So here we see our 45 is the one coinciding with the datum or the reference line on the barrel. So we say the thimble scale reading is 40, 41, 42, 43, 44, 45. Still we move it to 2 decimal points. So the third one is the thimble scale reading. Which is equal to 0.45. So these three, when we sum them up or when we add them up, we get the final reading of the measurement we've taken. So the final reading will equal, will be equal to the sum of all of these ones. So we get our 3.00, we add a 0.50 plus a 0.45. So here the sum, we are just adding them, simply adding them. We are having a 5 here, we have a 9, we have a point here, and we have a 3 here. So the reading we are having there is 3.95. So this is the accurate reading we have of a micrometer. So we are having a 3.95, and it's in millimeters. So this is the final reading. It's the final reading. It's in millimeters. All units are in millimeters. All of these we are writing. They are all millimeters. So we shall take another example of this micrometer here. The scales, we still count. This is, we first count the ones in 4 millimeters, the barrel reading in 4 millimeters. We said it's the upper one. This is 1, 2, 3. So the barrel reading, the barrel or sleeve scale reading in 4 millimeters. It's this one up. It's equal to 3.2 decimal points 00. Then we go, this is the first, the second one is the barrel or sleeve scale reading in half millimeters. So I explained we only take caution at this place here. If you're not seeing any line ahead of the 3, any marking ahead of the 3, that means you're not having any half millimeter. So this simply means you're having a 0.00. You're having nothing like a half millimeter. So the third one we take is the thimble scale reading. These are all millimeters. Thimble scale reading. So this is equal to, remember this scale is also graduated and the numbers are written there. They come from 0. Now it rotates 360 degrees, or it can rotate a full revolution. It comes from 0 up to, we said 50. The graduations are 50. So at this time around, maybe the 50 is the other side, we can't see it, or the 45 is the other side, or the 10 is also the other side, we can't see it. So we consider the ones we are seeing here, 25, 26, this is 26, 27, 28. Now the line, where the line coincides with this reference, it's 29, it's the measurement we take, it's the one we put here, it's 29. So it's after the decimal point of 0.29. So the sum of all these measurements will give us the final reading. And this simply means if I get the 3, when we add the sum, we start from this side. We have a 9 here, we have a 2 here, we have a point, a decimal point here, and we have a 3. And these are millimeters. So basically, the reading of this micrometer here, the final reading is 3.29 millimeters. So depending on the gap between the spindle and the anvil, after taking the measurement, we go to these scales and read and interpret the graduations, and we come up with the final reading, which is at the accuracy of 0.01. So this is 3.29 millimeters. So basically, that's how a micrometer is read, and I hope you've understood how to read the scales and how to use it. Basically, that's how we read after taking any measurement. Take for instance of this shaft of ours. We've took the measurement. So we go to these scales and we do as we have said here, as we've explained here. So we read the measurements, the barrel or the sleeve scale measurements or readings in 4 millimeters. We read these ones in half millimeters, but our main point of focus is around this place. Whether we are having a 0.5 ahead of the 4 millimeter, or it's behind, here it means we are having a 0.5 already, and when it's behind, it means we are not having any point, any decimal point of 0.5. So basically, that's how we read a micrometer, and I hope you've understood. I remain Isaac from the Innovation Consortium. Thank you very much. Keep tuned in for our next episodes of How To. Thank you.